In this video, I'm going to start introducing the concept of the mole. So in chemistry, the mole is a counting unit. So it's a word that has a numerical value. And so this is often compared to things like a pair. So if you have a pair of something, then you have two of it. So if we use cats as our example, if you have one pair of cats, you have two cats. If you have one half dozen of cats, you have six cats. If you have a dozen, you have 12 cats. If you have a grouse, you have 144 cats. And if you had one mole of cats, you'd have 6.022 times 10 to the 23 cats, which is a very large number. And in fact, if we look at it this way, so if we have 10 to the 0, that's just 1, 10 to the 1 is 10, then 100, 1,000, a million, a billion, a trillion, a quintillion, a sextillion, and 10 to the 21 is 1 septillion. So something on the order of 10 to the 23 would be on the order of 100 septillion. So the 6.02 times 10 to the 23 is 602 septillion. So this is a very large number indeed. It's a 6.02, and then there's going to be 21 zeros after it. And so Avogadro's number is so large because atoms and particles are so small. So a single atom is far too small to weigh. So it weighs about 3.348 times 10 to the negative 24 grams. And so we need lots of atoms or particles to get enough mass if we want to weigh it in the lab. And so Avogadro's number is very large so that we can get enough particles to actually weigh. And so we want to use the number that's shown on the periodic table for the mass of the compound. So the number on the periodic table is an AMU, atomic mass units, which is the mass of a single atom. So for example, a carbon atom has a mass of 12.01 AMU. If we have 6.022 times 10 to the 23 atoms, then we have that same number as is shown on the periodic table, but in grams instead of AMU. So 6.022 times 10 to the 23 carbon atoms have a mass of 12.01 grams. So we see we're using the same number, but now it has the units of grams rather than AMU. And so Avogadro's number comes from the conversion factor that 1.000 grams is equal to 6.022 times 10 to the 23 atomic mass units. And so if we have 1 mole of anything, that just means we have 6.022 times 10 to the 23 of that thing. And so we can use atoms or molecules or ions or whatever. So 1 mole of gold is that many gold atoms, 1 mole of water is that many of water molecules, 1 mole of NaCl is that many NaCl formula units, which is just the fancy word for essentially molecules of ionic compounds. 1 mole of chloride is that many chloride ions, 1 mole of methane is that many methane molecules. And so we can use this as a conversion factor, the fact that 6.022 times 10 to the 23 particles is equal to 1 mole. So if we want to look at a few of these examples here, how many water molecules are in 0.750 moles of water? So we want to start with our moles of water. So we have 0.750 moles of H2O. Then we use the conversion factor here, so the moles of water on top at the left will cancel with the moles of water on the bottom over here on the right, and then we're just using the fact that 1 mole is equal to 6.022 times 10 to the 23 molecules of water, and so the units of moles will cancel out. We'll end up with just the molecules of water. And so if I gave you 0.750 moles of water, that would mean that I gave you 4.52 times 10 to the 23 molecules of water. The next one, a sample of gold has 4.5 times 10 to the 24 gold atoms. How many moles of gold does the sample contain? So we want to start with our atoms here. So that's the 4.5 times 10 to the 24 atoms. And then we want to use Avogadro's number as our conversion factor. So this time, because we want the units to cancel out, the 6.022 times 10 to the 23 atoms of gold will be on the bottom. And so that would cancel out with the gold atoms on the top over here. And so we would just end up with moles as our units. And so that would give us 7.5 moles of gold. And so what that means is if I handed you 4.5 times 10 to the 24 atoms of gold, you would know that you had 7.5 moles of gold. And so we can use this to actually come up with the number of moles of each atom that are in a molecule. So if we are given these three molecules here, so water, AlCl3, and then benzene, what we would see is that the number of moles of each atom in 1 mole of the molecule would be this. So water has 1 mole of oxygen in 1 mole of water, and 2 moles of hydrogen in 1 mole of water. AlCl3, if I gave you a mole of that, you would have 1 mole of aluminum and 3 moles of chloride. If I gave you 1 mole of the benzene, you would have 6 moles of carbon and 6 moles of hydrogen. And so we can use these conversion factors here. So if we have water, 1 mole of water to 2 moles of hydrogen, or 1 mole of water to 1 mole of oxygen. With the aluminum chloride, 1 mole of AlCl3 to 3 moles of Cl, 1 mole of AlCl3 to 1 mole of Al. Then benzene, 1 mole of benzene to 6 moles of hydrogen, and 1 mole of benzene to 6 moles of carbon. So let's look at a few examples to see how this works in practice. How many moles of hydrogen are there in 0.750 moles of ammonia? So we want to start with our 0.750 moles of ammonia. Then we want to use the conversion factor of moles of ammonia to moles of hydrogen. So there are 3 moles of hydrogen and 1 mole of ammonia. And so the moles of ammonia will cancel out, and we are left with 2.25 moles of hydrogen. In other words, if I handed you a container that had 0.750 moles of ammonia, you would know that you were also holding 2.25 moles of hydrogen, which are contained in the ammonia. The next one, how many moles of Al2O3 contains 4.50 moles of oxygen? So in other words, I'm telling you how much oxygen you have, and you want to know then how many of these Al2O3s you have. So we'll start with our 4.50 moles of oxygen. Then we want to use this conversion factor here. So there are 3 moles of oxygen to 1 mole of our aluminum oxide here. The moles of oxygen cancel out. We are left with just moles of the aluminum oxide, and so we see that this would be 1.50 moles of aluminum oxide. The next one, we have how many moles of oxygen are in 1.25 moles of sulfate ions. So sulfate ions, SO4 2-, we would want to start with our 1.25 moles of the SO4 2-. Then we want to find out how many moles of oxygen are contained in the 1.25 moles of the SO4 2-. So we would use this conversion factor here, the fact that there are 4 oxygens in 1 sulfate. So there are 4 moles of oxygens in 1 mole of sulfate. The moles of sulfate will cancel out, and we are left with just moles of oxygen, so we get 5.00 moles of oxygen. So again, in other words, if I handed you 1.25 moles of sulfate, then you would know that it also contains 5.00 moles of oxygen. The next one, how many moles of the iron 3 sulfate contains 7.50 moles of oxygen? So again, we're saying how much oxygen we have, and if we had this much oxygen, then how much of the iron 3 sulfate must we have? So we want to start with our 7.50 moles of oxygen. We use this conversion factor here. So this 3 on the outside of the parentheses has to multiply the 4 inside the parentheses. And so that's why we end up with 12 moles of oxygen here. So it's 12 moles of oxygen in 1 mole of the iron 3 sulfate. So the moles of oxygen will cancel out here. We'll just end up with the moles of iron 3 sulfate, and that would be 0.625 moles of the iron 3 sulfate. So again, 7.50 moles of oxygen, if they are all contained in iron 3 sulfate, would mean that you have 0.625 moles of the iron 3 sulfate. And so here are a few practice problems. I encourage you to pause the video, try these on your own. I am only going to give the answers here. I'm not going to go through how to solve the problems. If you got the wrong answer, then I would encourage you to go back and look at what you did and try to come up with the correct answer. So for the first one, we have convert 1.111 moles of this calcium phosphate to moles of oxygen. And so if you did that, you would end up with 8.888 moles of oxygen. The next one, we have convert 6.54 moles of water to moles of hydrogen. And so that would give us 13.1 moles of hydrogen. The next one, convert 3.45 times 10 to the negative 4 moles of the iron 3 oxide to moles of iron, and that would give us 6.90 times 10 to the negative 4 moles of iron. The next one, if you have 8.00 moles of nitrogen, how many moles of the tetranitrogen dioxide do you have? And so that would be 2.00 moles of the N4O2. The next one, if you have 6.3 times 10 to the negative 5 moles of hydrogen, how many moles of the aluminum hydroxide do you have? And so if you calculated that out, you would get 2.1 times 10 to the negative 5 moles of aluminum hydroxide. The next one, if you have 32.00 moles of oxygen, how many moles of tin 4 phosphate do you have? If you calculate this out, you would find that you have 2.000 moles of the tin 4 phosphate. But anyway, that was everything I wanted to talk about in this video. I hope you found that helpful, and I will see you in the next one.